Thanks for joining us for the There's a Tool for That webinar. This webinar is going to demonstrate some commonly useful tools available in OpticStudio in both sequential and non-sequential modes. So why do we want to do this? Well, time is money, is the short answer. The less time that you spend modeling your system, the more time that you can spend doing the building, testing, and producing the final product. So our goal in this webinar is to help you get through more of the tedious tasks in the design part so that you can get to the end product faster. And we can help you be able to produce something from it. So the goal of this webinar is to help you become familiar with some of the useful tools in OpticStudio that you may not have known existed until now, or maybe you saw the button and you didn't know what it did. It's absolutely fine. We're going to go over some of the more useful ones that we've noticed might pop up in a lot of systems. So the goal is to speed up the modeling process in doing this and to help us understand what tools you need to use to get the job done. So at the end of the webinar, we're going to have a Q&A section where we'd love to have you submit different ideas for tools that we can add or incorporate into the system. Or if there's a suggestion for one that already exists, I can point you in the right direction. But then we can go ahead and document that and put them into new feature requests so that we get more user feedback on what you guys really need. And so the tools that we're going to look at today are the tilt and decenter tool, add fold mirror tool, the put apertures on surfaces and insert lens tool for a sequential system. And then we're going to look at some non-sequential tools as well, such as the modify reference object and the replicate object or replicate non-sequential object. Just note that OpticStudio has a lot of other tools, but this webinar is going to address these specifically. And if you have any questions about the other tools or how these work or what tools there are in OpticStudio, you can feel free to ask during the Q&A. So we're going to start with a scanning mirror example. For this example, we're going to go through and do the tedious part first to show you what you would have to do it by hand. And it's just going to be a simple scanning mirror. And then we're going to go ahead and show you how to do it with the tools that I've mentioned and how that will speed up the program. So let's go ahead and open up OpticStudio. So this example is going to go through a quick scanning mirror example, and we're going to go through and do it by hand first to show you all of the more tedious parts to it, just to get an idea of how much more useful it is to have all of these tools and how much faster we can get through those tedious parts without having to worry about everything, all the little details of it, and get you to the designed end. So we're going to open up OpticStudio here, and we're just going to start from scratch. So we'll fill in an aperture of 40. And we're going to leave the fields at the on-axis field only, and the wavelength set to the default 0.55 microns. So we're not going to mess with those, but we want to make sure we fill in the aperture. So we can open up the 3D viewer now. We're going to insert 3 surfaces. Insert. Insert. And every time you use insert surface, it's going to insert one right above the current surface, unless you use, but you can use insert after, which will insert one after that. So we've got our 3 surfaces, and let's give them some meaningful names. So this is going to be our mirror. This is going to be the front of the lens. And this is the back of the lens. I'm going to use the auto width just to make everything look clearer. And let's give these some thicknesses. So we'll go with 50, 50 from the mirror to the lens, a thickness of 10 for our lens, and about 90 from the back of the lens to the image plane. So we can see that here. Let's go ahead and construct our lens. So we want to use NBK7. the typical workhorse glass. We're going to give it radii of 100 and -100. And just to make this plot prettier, let's go into the properties. We'll reduce the rays to 3. And let's hide lens edges and X bars, so it'll just make this look a lot more like what we would expect from the cross-section viewer. Okay, so here we've got the beginning of our system. So the first thing we want to do is turn this into a fold mirror. To do that, we're going to have to insert a surface before that and insert a surface after, and set these to be coordinate breaks. Okay. And these coordinate breaks are going to tilt about x, since we're looking down the x-axis. We're going to have them tilt by a total of -90. So we want -45 and -45. And now we can set the material to mirror. Great. So as we can see, there are quite a few problems, and that's because we haven't gone from mirror, from normal space to mirror space. So the first thing we want to do is put that value here and negate that value. So we're going to change that to 0 so that there's no distance between where the mirror and the next coordinate break happen. We can see we've still got some issues there, so we're going to change all of these values to be negative. So -100, +100 there, -10, and -90. So now we see that we have our folded mirror there. And it took us a little bit of working through this part, but we got there. Okay, so now that we have our folded mirror, what we want to do is make it scan. So we're gonna go ahead and insert 2 more coordinate breaks around that. Insert surface after, and we'll set them to coordinate breaks. Let's call these element tilt. Then element tilt return. Just so that we know that these two go together, and this one is going to correct the rest of the system for the top one. So let's have it tilt by 5 degrees. We can see that everything else is tilted here, so we're gonna go ahead and change this to pick up from that surface 3 current column, and we're gonna give it a scale factor of -1. There, so now we've got the first angle of our scanning mirror. We can go into open up the multiple configuration editor, and we'll add 2 configurations. So the parameter that we want to use, or the operand we want to use, is called pram, and that's just going to change the value of a specific parameter. And so for the coordinate break, since we want this value to change, we're going to look at surface 3, parameter 3. So we can go into the properties here and change that. And we can tell that we've got the right one because we've got our default 5 set in there. So we're just going to change this one to 0 and the next one to -5. And you can see the different configurations there. So the next thing we want to look at, these thicknesses change while we go through our different configurations. So we want to make sure that we get that fixed. So we're going to take each of these clear semi-diameter values and we're going to use the maximum solve on them. So you can hit the little solve column there, go into solve type for the clear semi-diameter, and you want to hit maximum. We're going to do that for all of the clear sigma diameters with a value. So this one's going to be maximum. We're going to set this to maximum, maximum, maximum. And you can see already that that's changed the sizes of all of these. So now if we go into the properties here, let's look at this colored by configuration number, and let's look at all of them. If I hit OK, you can see that the system looks the same other than the scanning mirror, which is exactly what we want. Okay, so we got through that. It was a little bit tedious, but we did it. So now I'm going to go ahead and open a new file, and I'm going to put that together using the tools that I mentioned before. So we're going to set the aperture again to 40. Fields stay on axis, and the wavelengths will stay at 0.55 microns. I'm going to go ahead and insert 3 surfaces, and you can do this by selecting the lower surface and just hitting insert 3 times. That'll insert one above that current surface. Again, I'm going to call this mirror, front of lens, back of lens. And let's go ahead and give these thicknesses. So 50, 50, thickness of 10 for the lens, and 90 here. So let's go ahead and open that up in the 3D viewer. And just a note, we're using the 3D viewer instead of the cross section because we know that when we put in our coordinate breaks, this one is not. We're not going to be able to use the cross section anymore. So we'll go into those properties. Again, I want to make it a little bit cleaner. Let's bring that down to 3. Hide lens edges and X bars, which we don't have them yet, but we will. And while we're at it, why don't we just change that to configuration number? Okay, put that down here. Let's give these our radii of 100 and negative 100. And let's give this a material. Again, we're using NBK7. Okay, so now we've got that initial system that we had before. Now instead of putting in the coordinate breaks manually, if we want to select the surface with the mirror surface that we're going to use, and we can use a tool for that. So if you go up here to the little bar at the top of the lens data editor, we can find the add fold mirror tool and the remove fold mirror tool. And so we're going to use add fold mirror, and we want the fold surface to be 2, the one that we've selected as our mirror, and the reflect angle to be negative 90. And we hit OK. And it's done all of that work for us. So you can see that the negative 45s have been put in there, but also the value that was on this surface moved there. And all of these values are negative now. So we've got our perfect folding mirror system there. Oh, with the touch of a button. So the next part we want to do is we're going to add our tilt to this so that we can have it scan. So we're going to go up here and use another tool, the tilt to center elements tool up here that looks like that. We click that. We just want it to apply to this surface, surface 3. So that's the first surface and the last surface, and we're going to give it a tilt of 5 degrees. Let's change the color so that we can see it better to color 4, so that nice yellow. We're going to hit OK. And there we have our extra little angle there at the beginning of our scanning mirror without having to go through any big problems there, which is good. So now we can start adding our configurations. We'll add 2 configurations like we did before using PRAM and setting surface 3 and parameter 3 as the values. So we're gonna scan through 5, 0, and -5. And we can see all of those different tilts of the mirror. We see again that the size of this lens in this configuration is not the same as the size of this lens. So let's go back and put more of those maximum aperture solves. But wait, there's a tool for that too. So we can go up here to the little circle. This tool is called Put Apertures on Surfaces. So we can click that. It'll give us a little drop-down menu. We have Remove All Apertures, Convert Semi-Diameters to Circular Apertures, Floating Apertures, Maximum Apertures, and Replace Vignetting with Apertures. And you can see the information for all of those when you hover over them. So what we're going to use is Convert Semi-Diameters to Maximum Apertures. And once we click that, you can see that all of the maximum solves are there, and it changes on its own. We didn't even have to go through and do that manually. So now we can confirm that all of our systems look the same and it looks just like our last one, which is great. So now say, what if you didn't want to use this typical lens to model your system? What if you wanted to use, say, a doublet, but you didn't want to go through and have to make the doublet by hand? Well, there's a tool for that too. So we can just go ahead and delete those surfaces. Oh, I accidentally inserted one. Delete that. We're gonna go ahead and insert another lens file in there. So if we go into File, we can hit Insert Lens, and we can just find the file. So I've got a doublet that I made that I want to put in there. So I'm gonna just open that file, and I want it to insert at surface 7. And it's gonna ignore the object and change the sign of the surface in mirror space, which is good because that's exactly what we need. And so I'm going to hit OK. And there we've got a doublet. Got to fix some of the apertures here. So for one, this surface, which I believe was originally the stop in the other system, we don't need that here. So we can just delete that. And then we can set these to the maximum aperture as well. And there we have it. We've got our scanning mirror system using a doublet lens just off of this one tool. So that'll be useful for inserting different lens files into your the file that you're working on now. You do want to make sure that the semi-diameters match up for the system. So for example, if the doublet that I made used an aperture size of, say, 10 millimeters, then it would insert that lens at 10 millimeters for these, which would not fit into the system that I have. So you have to make sure that you fix those and any changes in the lens that might occur from changing the size of the lens. But it's a great way to take something that you've made before and put it into that new system. Just keep in mind that it can take a little bit of troubleshooting before that new system works ideally. But it still saves you a lot of time in having to reconstruct that object or that series of surfaces. All right, so in that example, the tools that we used include the Add Fold Mirror tool, which adds coordinate breaks and pickup solves, converts the surface to a mirror, and converts the following values to mirror space as necessary, as we saw. We use the Tilt and Decenter tool, which will add coordinate breaks and pickup solves based on what your tilt is for it, but it can also apply to more than just one surface, so you can take a whole lens and tilt that all together, and the Tilt and Decenter tool will accommodate for that and add those tilts to all of them, and add the coordinate breaks around that, like group of surfaces. We use the put aperture on surfaces, which gives us a whole bunch of options to change all of the apertures. We used it to set all of the apertures to maximum solve, which just fixed all of the semi-diameters in our configurations. And finally, we use the insert lens tool, which lets you put an entire different lens file into your current system. And that can save you a lot of time just in trying to model something that you've done before in that new system. So next we're going to look at some non-sequential tools by doing this quick little non-sequential geometry example. So let's go ahead and open up Optic Studio again. We'll open up a new file. And let's set it to non-sequential mode. Yes. Okay. And so we're going to go ahead and take a look at some of these tools here. We're going to use the replicate objects tool, as well as the modify reference objects tool. So let's start with the replicate object tool. So let's go ahead and say this is a rectangular volume. We can open up the shaded model. We'll put that there. And just so that we can get a better view of it, let's change the Z length to 0.1. There we go. So now we can see that. Let's change the view to XY. Great. So what we're going to do is we can open up the replicate object tool, and we'll set the object to object 1. So it's going to pick up this object, and it's going to turn it into an array. So now you could use the array object tool for this, and for simple arrays that would be ideal because then it'll trace a lot faster, use a lot less memory. But sometimes you want to construct an array of individual objects that might be able to move by them individually apart from the other ones. So we're going to go ahead and try this tool out to give you an idea of what the capabilities of this one is. And yeah, so let's create two replicas in the X direction and 2 in the Y direction, and we're going to give it a distance of 10 between each other. We'll add pickup solves and add relative references and hit OK. So now we can see that we've got our little array of 4 rectangular volume objects, and we can see that they're each their own object. So the next thing I want to do is I can highlight all of these. So we're going to use the modify reference object tool just to, we'll put them all, so we can see that these are all referencing each other. So we can set them all back to global coordinates or have them all reference volume, the first one. So let's go ahead and set this to, let's actually set it to reference object 1. Okay, so it didn't really change because object 1 is at the origin, but let's say we want these not to be at the origin. So let's say we want this not to be at the origin. So let's go ahead and we'll set this to -5 and this one to 5. And you can see that that doesn't change anything in here because that's the reference object. And so all of these values are referencing these values. Whereas if you were to say change this to 5, you can see a noticeable difference there. So now that that's all set, we can actually see what the new coordinates are of these by setting those to reference global coordinates again and hit OK. And we can see that that's changed the values here, but not the positions here. Oh, oops, I did a thing wrong. I actually want this to be -5. That way the center is around here. We'll go back through that and set this to global coordinates. Okay, and now we can see that they're all around that center here, that origin. And so the other good thing, nice thing that we can do with the modify reference object is to use it as a way to tilt about a pivot point. So if we insert a surface here, just a null object, let's call it pivot point. So we're going to use that to tilt the rest of this volume. In order to do that, we're going to just highlight these, not replicate, my bad. Modify reference object, and we're going to have it reference that pivot point. Okay. And now if I were to tilt the pivot point, say 30 degrees about Z, you can see that they all spin about that center axis. You can also see that once I change this back to global coordinates, all of these position values are changed to accommodate for that change in distance there. So it's not just giving them that tilt value, it's changing the entire position based off of what your pivot point is, which can be extremely useful for certain non-sequential systems. And you can also have it change, say, tilts here relative to that first one. So the modify reference object tool is very useful in changing the relative tilts and distances of all of these objects in non-sequential mode. And when you're done with the pivot point, if you don't want that null object in your system, you can always delete that, and these values will stay exactly as they are. Great. So the tools we ran over in that one were the replicate object or replicate NSC object tool, which will generate an array of independent objects. Again, you can use an array object to do this, but that array would move as a unit, whereas this will just create an array of unique objects. So if you need the objects to turn individually, you can go ahead and do that there as well. And then modify reference object will set a list of objects, a series of objects to reference another specific object that you define there, or reference global coordinates so that you can see globally what those coordinates actually are. And it'll adjust all of the coordinates accordingly based on what the reference object is. And so a few more time savers that you might want to take a look at or mess around with just to speed up that design process again. We have a bunch of shortcut keys that we offer in OpticStudio that you can find under the Setup tab, Project Preferences, and Shortcut Keys. So if we open that up, we can go into Project Preferences, Shortcut Keys, and we've got them all here. So these are all the basic ones. These are all the active shortcuts. And if you like, you can add some of the available shortcuts. So you can see the lists here. If you don't like those, you can always. So for example, for the 3D viewer, if you don't like having that as the shortcut for it, you can either change it by clicking here and selecting a new shortcut. If you don't need a shortcut for that, you can always click this arrow here and it'll go away. Or if you want a shortcut from the available shortcuts list, you can click the arrow when it's pointing left and add it there. And you can give it a shortcut if it doesn't already have one. So this one doesn't already have one, and it'll have enter shortcut, and you just hold down the keys that you want it to use. And the more you use those shortcut keys, the more it'll be ingrained in you, so that the next time you want to open up the 3D viewer, you just hit Control-Shift-L without having to go into the Setup tab or the Analyze tab and look for a 3D viewer. Or if you want to optimize the system, you just go ahead and use Control O, and you don't need to go through and find those things. So that can be a pretty decent time saver. Another good thing to save some time during the modeling process is to do a system check. You can find the system check button in the setup tab. It looks like that. And it'll show you a bunch of common errors, warnings, and trivial warnings in your system. The main thing you want to look for are errors, but this will be extremely useful to you when you're running into a certain error or calculations aren't coming out the way that you expect them to, and you can go ahead and do your own troubleshooting without having to go through every single step. And it won't catch everything, but it can catch a lot of basic things. And the main thing you want to look for are the errors, but sometimes you can find warnings that will tell you, oh, if you use this, it looks like you've checked this. Just so you know, if you're using this, then like the values for, say, the F number may not be correct, and you want to double check that or something along those lines. So we can take a look at that. It's under the Setup tab. Open up System Check. And we can see that in addition to the errors, warnings, and trivial warnings, so there's a little definition of what those are here. It'll give you your information there, your memory usage, and it'll list the different warnings, errors, etc. here, so that you can take a look at those and make sure that your system is behaving the way you want it to. And finally, we are always open to getting more suggestions for different types of tools that you may feel like are used enough by you or by people that you know, or just in general that you think we should add into our system. So are there any common procedures that you use repetitively in OpticStudio that would make a really useful tool? Feel free to send us your ideas through the GoToMeeting or GoToWebinar chat, and we can go ahead and document that information and submit it as a new feature. Or if I notice that we already have a tool to do that, I can let you know, and we'll be able to try to follow up with you on that. And so it's time for the Q&A. So you can go ahead and submit any questions, again, tool suggestions into the little chat bar, and I can go ahead and answer those for you. Okay, a little bit of technical difficulties for a second there. So as far as relative illumination to show the field, currently we do have a tool that lets you convert to a non-sequential group. And so if you've defined, for example, the double Gauss with fields, and let's give this some thickness so that it's not coming in from infinity. Oh, I guess it can come in from infinity. And then you go into convert to NSE group. We'll just leave all of that and hit OK. And as it does the conversion, it'll create the different sources at different fields. So if you wanted to start a non-sequential file if you wanted it to generate fields, then it might be useful to do that. But that is a good suggestion, and we're going to go ahead and make sure that that gets taken into account. Does the add tool mirror feature work with multiple scan mirrors also? Let's go back into this. So the answer is yes. You can always add another surface in. So if I go into the lens data editor, and you just put a surface in here, insert. Where is that? That's right there. So let's put a thickness here of, say, -10. And now I can go ahead and use the add fold mirror again. the last one I think was 90 degrees, so let's make, or negative 90 degrees, so let's make this tilt in the 90 degrees. And it'll create another one. We've got to change some of the distances that we've gotten here. Just to separate these, I'm going to add another dummy surface so that I can see the little space there. The surface does nothing. Let's increase this value. And then we'll change this to maybe 50. And up this to 18. That's close. So it will work. Let's make dummy surface. We can get rid of this now. So it does work with multiple scanning mirrors. And the reason that it looks a little ridiculous right now is because this mirror is being tilted, so we've got all these different configurations happening. So you can feel free to add in as many surfaces and turn those surfaces into tilt mirrors. Okay, so the question is, how do you scale or rotate a file in Zemax? So I'm not entirely, I don't completely understand what part, so it is can go ahead and look in the 3D layout at the system, can do specific rotations by setting the properties here. So if I wanted to look at specifically a rotation of 90 in the Y direction, then I can see that that's happening there. As far as scaling design, you can, we have an option for that. If you go into the Setup tab, you can scale the lens. And you can choose your scale factor, so you can, it'll just decrease everything by some value or increase everything by some value. So if I put in a scale factor of 2 and my list of objects, or you can scale it by units. So you can change all the units from millimeters to inches or centimeters. And that'll just change the values that you've got. So if I scale all of these by 2, I've got the same system, slightly bigger. Here, let me fix that view. So there's a question about sequential ray tracing and how to see relative illumination on the image plane. So relative illumination and other illumination based things in OpticStudio are all going to be in non-sequential mode. So if you're working with a sequential system and need to know about the relative illumination, again, you can try the convert to non-sequential group. There's a great webinar in our archives about stray light analysis, in which the presenter uses I think they use the double Gauss file, converts it to non-sequential, and uses that to analyze the stray light in the system. So that's always an option. But currently for illumination-based information, you want to use non-sequential. That's exactly what non-sequential is for. So someone asked how to set up the mirror rotation about a plane axis, and so we've only got the option to fold a mirror about the X or the Y, and currently not a combination of both. Put that in as a feature request, because it does seem like it'd be a really useful option to have. The webinar for that should be, so you should be able to find that just by going to our website. So it should be under Optic Studio Recordings under the Webinars tab, and that one's just called, oh here, Methods for Stray Light Analysis in Optic Studio. Someone's asking about the check mark in the Replicate Objects tool where it says use relative references. So I can go ahead and take a look at that one. So relative references just means that, the reference is, so when relative references isn't checked, it's going to use absolute references, which would be, for example, if I'm trying to reference object 3 to object 1, it would put into the reference object category 1, whereas a relative reference means that I would use a negative value, like -1, so that that object always refers to the object right above it, even if I add objects to it. So if I add another object above that object, then it'll reference that new object instead. And so in the replicate NSC object example, if I were to replicate object 1, each of the subsequent objects would just reference object 1 if without that checked. So these would all say 1. But with it checked, this would say -1 because it'd be referencing that, -2, and -3 because then it would be 3 surfaces before. And so that could be useful for if you just want to change that first object, or if you want to add a different object for them to all replicate or to reference, then that can be useful. Is there a scanning tool that lets you make the multi-configuration operands the way that we did by hand? Not yet, but I can go ahead and add that to the list of tools that we can go ahead and add. So does anyone else have any ideas for tools that we want to try to implement? Anything that you do consistently? Okay, so changing the face settings on CAD objects, that's a really good one. Yeah, and currently we do have like the option for figuring out which of the faces is which, but being able to change that and select different areas as faces would be a good option. Some really good feedback since we are working on making everything more user-friendly, so getting a lot of the information from you all that on the different tools that you use or the tools that you'd like to see implemented is really going to help with how OpticStudio moves forward. Well, thanks for all the questions, and if you have any more, feel free to send it to support@zmax.com. Thanks for attending this webinar.